Okay, so we're already 5 minutes in, so I guess I will just start. I hope for a little bit more people here, but well, fair enough. So I wanted to talk a little bit about maybe bootstrapping a LoRa-based Linux project. This is not really a session where I would just stand here and teach you and tell you about things or something. That's more a session where I actually wanted to have more participation. Because this project is not really started yet or something. That's more like getting input from other parties, getting feedback, and see if you want to have something like that. Or if there's no need at all. I mean, we don't have to start something if nobody wants to use it. So just a little bit of background on myself. So I'm a FOSS contributor since a long time already. I was a user before that. An EFL, that's Enlightenment Foundation Libraries, which is powering the Enlightenment Window Manager. I'm a developer there. I'm the release manager of the libraries. I'm also the subsystem maintainer of the 1504 subsystem, actually started by one of our attendees here a long time ago. And I'm also the team lead of the Samsung open source group in SIUK, which is the Samsung Research UK department. So a little bit of an agenda. I mean, as I said, I don't have that much slides. I really want to maybe get some feedback here. So I would first start with an idea statement. So that is why I'm actually thinking about starting something like that. Then what we currently have in terms of current work and resources that are available for that, and then go into the discussion phase here. Okay, so when I talk about a LoRa subsystem, I mainly target something like gateways or something, because normally I would expect that the LoRa end nodes would use an RTOS-based system, maybe to make sure that they run not out of battery power or something like that. But it could be also used for systems that actually have main power or something. I don't see Linux in a use case for like really sensors or something, but for a gateway that's really connected to the backhaul and everything that might want to spawn up your radio stuff, that's a different thing here. The main reason I wanted it, or actually I think that's a good idea, would be to use the main networking stack that's already there, use all the features it has, all the normal configuration options it has. Because what I normally see in these scenarios with a new wireless technology comes up, there's like something like a network coprocessor design where you just have a board with a specific firmware and everything attached to it, and then attach that to your Linux box. And then you have like something like serial line IP interface or something, just get everything dumped over there. It works, and if all the people involved doing that are happy with it, I'm not going to paint it as black as I might see it, but in my personal opinion, you can really use a lot more stuff that's already there. I mean, there's a lot of optimizations going on in the networking sector, a lot of new features coming. I mean, just think about all the normal firewall stuff, the traffic control, even something like extended Berkeley packet filters, something new like, I mean, that's not relevant that much in performance for LoRa, but if you go for like express data paths or something, that could be interesting. So the main idea came when someone submitted a driver for an actual LoRa transceiver to the linux-wpan project, which I maintain as a kernel. They wanted to use the 15.4 specification over this transceiver. And I was really skeptical why they wanted to do that, and because the problem there is you have no compatibility at all with other LoRa network stuff out there. So they had a use case where they only used it between two different devices, and there was no other stuff in the Linux kernel they could use for it. So they chose the real quick way and just brought the transceiver driver and want to use our Mac stack for that. They might do that. I don't know what their products or use cases are really. But for me, that really spawned up the idea why we are not going for a full LoRa stack on that side. So that's where I also started. Right now I'm in the phase where I'm gathering information, so I have like 1 or 2 people in the community that are interested in that, and I might have 1 or 2 companies that might have interest in that or not. So I'm wondering if anybody here actually want to do that, or if people are here more for like understanding the technology behind it, or if they actually would use it in a product or something. So what kind of resources do we have right now? So LoRa is a long-range, low-power specification, but there might be others. So there are Sigfox and other things. So if anybody has recommendations, what else is out there that we can actually use in terms of there's a public specification we can actually use for implementing the stuff, and there need also be some hardware available. So if it's just something that's really great, but you can't access to the hardware, that doesn't really fly well. So on the LoRa side, the homework I did so far is that there's a LoRa spec is available. It's not that big, and the spec itself is not that complicated. I'm not going too much into the technical details here because that is really not the target for this presentation. And another interesting thing is that the whole link layer security stuff is actually shared with, well, it's not shared. It's actually very similar to what 15.4 does. So that could be something that could be shared later on in the kernel subsystems. Also, there's, if you go on the higher up on the stack, you want to have like IP transfer over it. You want to actually look at header compression, and we have a 6-LoWPAN header compression subsystem in the kernel, which could be extended for other header compression schemes like static context header compression. I come to that in a minute. So that's something that actually is used for low range, low power devices, and we could extend that in the Linux system as well. So as I mentioned, there's a driver that was already posted that's still sitting on the main list right now. I haven't applied it because I could apply it to my subsystem, but there would not be a real use case for that, so I'm just letting it sit there for a while. What other resources we have available? I mean, there are other stacks. ARM Embed has a stack integrated. There's LoRaNet as a project directly on GitHub, which is kind of a reference implementation, mostly for endnodes. There's also work going on in Zephyr and Wire to actually get LoRa stack or LoRa support for the hardware. So that's something we actually could do compatibility testing against. Another big resource that's available is the Things network, which is like a community-driven network using LoRa gateways to, well, go over the whole world, basically. I mean, they're covering a lot of countries already, a lot of cities already. So that's one of the things where I think we could actually make a big impact if we provide them an easier way or a cheaper way to set up gateways. So what kind of hardware is there? There are the normal cheap transceivers you can get, like an SPI device with some extra GPIOs for signaling and stuff like that. So one thing, if you really want to get it started, one thing that would be good to have like building a head for the Raspberry Pi, just because it's so commonly used. Also interesting could be to have build a 969 board. But that's not really up to me. That would be another company doing that. I'm not really doing hardware development or something. And if you really want to get developers involved with that can use it on their normal laptop or a workspace machine, having a USB dongle sitting there with a really thin firmware in the middle of it, that might be really convenient. I did a lot of support for that on the 15.4 subsystem I maintain, and that really helped a lot to get developers into the project because they don't have to set up all the hardware, which sometimes makes it complicated. So as a potential roadmap, again, that's all potential, so I'm not saying we are starting that, because if I'm not getting enough interest, I don't think it's worth actually going there. So what we should or could do would be like having the normal kernel setup, have like a vger main list, have a patchwork GitHub, and have a hosting of the kernel tree and so on. One of the first things we should do is taking the driver, make sure that we have a softmax stack that actually goes along with it. We might later on have hardmax devices, but for the first step, going with the softmax stack might be the easiest one, and then we actually can implement all the parts in the kernel anyway. Yeah, going to user space, we need some way of configuration. Netlink would be the way here to go here on the networking side. And you normally could hook up in a lot of all the tools and frameworks that are already there for like IP configuration and so on, but you still need some specific configuration options for LoRa in that case. Setting up networking keys or just specific physical parameters of the network or something like that. Yeah, we could start with just using the header compression schemes that are already there as a first start, and then we can go ahead and go with the static context header compression, which basically makes use of the case that LoRa network is a star topology, and you normally know quite well what the traffic patterns are, and you have all the nodes connected to your gateway directly. So that means you can really shrink down all the header of your IP that you actually use for addressing and everything, and bring it down to a few bytes there. So that's in a nutshell here. And you can exploit a lot of the things that actually are needed. And you can still make sure that you can have a normal like socket interface and use IP version 6 over it without really screwing around and having to refragment and all your big packages or something. Yeah, we would have to actually need to look around and test against the other available stacks. And one of the final goals could be to deliver a way for the Things network to set up a gateway in a way cheaper way. Because what I've seen right now from them is like, either you can buy a complete gateway box for like 400 euro or something, or you can go ahead with a Raspberry Pi and some self-built stuff, and then, but you still need an external board for the LoRa support, which is around 120, I think, even without taxes. So if you have like, if you go with a Semtech SPI chip for a few euro and then make a Raspberry Pi head out of it, that would be down to like 10 or 15 euro or something. That could make a big difference. Yeah, but I mean, it really depends if they want that or if there's a need or interest. So points for discussion that I actually have here. So is anyone here actually interested in this, helping out or having a business use case for that? Or are people actually happy with the situation, so they are quite happy to just go ahead with a network coprocessor and put that in their design and then go along with it? Or are there actually better alternatives? So is there, for example, what I found with Sigfox is that they're really a closed network and you have to pay subscriptions, fees and everything, and the specification is not available, so that's really hard to actually deal with from an open source perspective side. But there might actually be other specifications I haven't seen. My personal interest is really to go ahead and see what we can do in long range and low power. So it doesn't have to be LoRa, but that looks like the best bet we have right now. So, and with that, I would actually hope to get some input from you folks. Yeah, I expected something like that. So, go ahead, Dimitri.
Thanks, Stefan. Yeah, does this work? It should. Okay. I wanted to comment on the third question, or maybe just ask a counter question. When working on IEEE 15.4, we had this issue because additional coprocessor meant that the device could be smarter in terms of supporting more features compared to just a simple dongle connected to the through the SPI to the central CPU. Can you comment maybe if you have studied the LoRa specs or LoRa details? Will there be any difference between the networking coprocessor versus the SPI transceiver in terms of LoRa?
Okay, so I haven't really looked into all the details there, but for me it looks like the normal use cases can quite easily be done with a really dumb transceiver. If you have some specific use cases where you need real-time requirements or something, then it is obvious that you might be lucky enough to do it on the Linux side. I mean, there's a lot of work going on there, but you really have to figure out if that's enough or not, if the jitter is enough and so on. But adding another MCU in the mix and having like some kind of hardware offload on a really low power basis here, that could actually work. For example, the USB dongle I described. So what I do there is I maintain the firmware, I maintain the driver, and actually I helped a lot with getting the hardware design out and so on. And so far I'm just passing all the stuff through, but I could actually do hardware-assisted stuff for Atos, for example, doing it in there. I haven't done yet because there haven't been use cases for it, but doing that and getting it into the stack that we actually can offload it to the hardware, that should be possible. I mean, it really depends on what your use cases are, but I haven't seen any so far yet.
Do you mean the USB dongle for 15.4?
Yes. Yeah. I mean, we could do the same.
For LoRa.
Yeah, we could do the same. I mean, that is really what helped me a lot to get some more attention from developers there. And doing the same, I mean, it's a really easy design in the end. I mean, I'm not a hardware designer, but even I can grasp what's going on there. So, yeah, I mean, but you can also do that for your own boards or whatever designs you want to bring out. I mean, adding just another thing in there. I still think it's better doing it in a way where you can actually have it as a normal interface in the Linux networking stack instead of just having all the IP traffic piped over through your line there. Because you have more control over it, even if you offload some parts to an MCU.
Back to the previous slide, I don't ask you to go to the slide. What was the main, not this one, the main selling point when, yeah, I think this one maybe, yeah. So the main selling point for designing 15.4 inside Linux was actually to be able to use common tools like sockets, like common software, and more importantly, Wireshark, T-Shark, and traffic analysis on Linux in a normal way. So not having to reinvent all the traffic analysis tools. So this might also be one of the major selling points for LoRa. For LoRa on Linux.
Yeah, I agree. I mean, there's even more stuff. I mean, there's like something like SCAPI for doing network testing, or even patterns, and all the other networking tools that are getting developed by big companies that actually want to make sure that the networking stack runs correctly, packet generators or whatever. You can use all the stuff with some glue code, and for the other ones you always have to implement a lot more stuff, or even not able to use it at all. I mean, I see all the benefits, but I don't understand if there's enough in terms of people that actually want to do that. I mean, I could start that in my spare time as a hobby project. That's not a big deal, but really to get it off the ground a bit more quickly and actually get it used in real world scenarios, I'm on the way and actually finding out if there is use for that or not.
Yes, thanks.
Okay, so the rest was here for listening in. Okay.
Basically, 15.4 started as the internal company project, which was later transferred into the community. So maybe that's the way to go with LoRa. If it's that depends, yeah.
I mean, normally I would actually prefer it to be a community project and then be backed by some companies, because it's easier to do that way instead of just doing it all internal, and then you have to go through this is a huge bunch you already have, and then go through an external review process and everything.
Yeah.
So. Okay, so thanks again for coming here. Okay, not really what I hoped for, but I mean that's nothing you can be blamed for. That's fine. So okay, we'll see further if I actually will start it or not. So thank you.